Assalamualaikum student, welcome to my channel Learn with Fun by Zarar sir. So today I'll be discussing about Mosfet, its steps for fabrication. So let's start Mosfet and the fabrication. So Mosfet, it is nothing but metal oxide semiconductor field effect transistor. There are three terminal: gate, drain and source. So let's fabricate gate, drain and source, that is, let's fabricate MOSFET. So there are two types of fabrication of MOSFET or types of MOSFET. One is enhancement and another is depletion. In enhancement we have NMOS and PMOS. Similarly in depletion also we have NMOS and PMOS, and the combination of NMOS and PMOS is CMOS. So let's start the first with fabrication of enhancement and MOSFET. Okay, so I'll be teaching you fabrication of enhancement and MOSFET. So let's start. So this is fabrication of enhancement of NMOSFET. The color code is important over here. If you are using color or if you are using any software like Cadence or Microwind, this will be very important for you. So the red color denotes polysilicon, green color denotes N diffusion, blue color denotes metal, and yellow color denotes p-type diffusion. So first, this is substrate, which is P substrate. Do remember a basic fundamental: if the substrate is P, the MOSFET would be N, and if the substrate is N, the MOSFET would be PMOS. So this is P substrate, that means I am trying to fabricate NMOS. The opposite of MOSFET is substrate. Okay, so let's start. I'll take the first step. The first step is you need to take P substrate. This is nothing but the body of the MOSFET. Okay, the next step is deposition of SiO2 layer. The deposition of SiO2 does only mean that we are doing wet oxidation. That means Si plus 2H2O gives SiO2 plus H2 gas liberation. So this is the first step, that is substrate. Another step is deposition of SiO2. So this is my SiO2 layer. Now third step is I need to fabricate gate, and then drain, source, further, so on and so forth. The next step would be, third step is PLG for gate. Now see, this is very interesting step for PLG, that means photolithography. The full form of PLG is photolithography. So I use photoresist material, I take some mask, and then I use UV light, then the portion get removed and the PV material are removed by hydrochloric acid. So the next step is PLG for gate, and we get space, or we get the vacant place for the diffusion or polysilicon material. So PLG is very important step. It is used to create the space for the material diffusion or deposition. Okay, so third step is PLG for gate. Now let's move towards fourth step. The fourth step is deposition of thinox. Now see, this is also SiO2, my SiO2, and this is also my SiO2 layer. So this is also SiO2, this is also SiO2, but the difference between SiO2 is this one is wet oxidation and this one is dry oxidation. Now you know the symbol of MOSFET. You have polysilicon and you have oxide layer. This is very important. The reason behind this is create the capacitance for the flow of current, which you have already seen in my video, that how MOSFET works. So this is nothing but your thinox or SiO2 layer. Now fourth step is deposition of polysilicon. Now this is your gate. Okay, so do remember the first step is substrates, deposition of SiO2, PLG for gate, deposition of SiO2, and then deposition of polysilicon. Okay, the next step is PLG for drain and source. So PLG for drain and source means I create the space for drain and source. Again the same step, you need to take the mask, you need to take the photoresist material, and then it's this steps is nothing but PLG for drain and source. Now once you get space for drain and source, you need to put the ion in it. So the step for ion is diffusion of drain and source. Now you can look, you get half model of your MOSFET, that is, this is your gate, this is your drain, and this is your source. Now let's move further and see what happens. So now I again deposit thinox. See, deposition of thinox is very important step because it helps the designer to understand that there should be what we could say, not there should be no overlapping of one material to another. If you could see this diagram, this polysilicon can overlap or mix with diffusion layer. That's why we use Thinox steps again and again. Okay, so this is deposition of Thinox. Now next step is PLG for contact cuts. See, this is the contact cut that had been created. So this is my PLG, this part get removed, this is the PLG, this part get removed, and finally this is the PLG, this part get removed. So this is nothing but PLG for contact cuts. Now this is metal, deposition of metal. As I have already mentioned, blue color is for deposition of metal. Now the next step is very important. See, now if you could see this step, 10th step, deposition of metal, each and every metal terminal is connected to each other. That means my drain is connected to gate, gate is connected to source. Now I need to separate this terminal, right? So that separation of this terminal can be done using PLG for contact separation. So PLG for contact separation, this terminal get divided. See the space created. Next step is deposition of Thinox. Now Thinox is deposited. Again PLG for contact separation, thus the space get created, and finally deposition of metal. So this is the metal that get deposited. So this is your complete diagram, or I would say complete steps for fabrication of MOSFET. Now this is your gate, this is your drain, and this is your source. I'll repeat it once again so that you could remember what we have already studied. There are total 14 steps. Okay, the first step is you need to take substrate, deposition of SiO2, PLG for gate, deposition of Thinox, deposition of polysilicon, then the PLG for drain and source. See, PLG for drain and source, diffusion of drain and source, then deposition of Thinox again, then PLG for contact cut, this is contact cut, deposition of metal. Now I need to separate this metal, the PLG for contact separation, deposition of Thinox, PLG for contact terminal, and deposition of metal. So these are the total 14 steps that you need to remember. Now guys, this is the minimize or reduction of the real process of fabrication. In real process of fabrication, there are more than 100 and 150 steps. So to understand its theoretical part, I have reduced it into 14 steps. You can elaborate it using the book SMG and other books in which fabrication is explained in detail. But I have restricted myself to only 14 steps. So this is the fabrication of enhancement NMOS. The only change in enhancement PMOS will be that P substrate will be replaced by N substrate, and N diffusion will be replaced by P diffusion. Hope you like the video. Please subscribe my channel, share it with your friends, and do comment whatever you understand out of it. In the next video, I'll be explaining you fabrication of depletion NMOS. There would be only 2 steps more. Okay, so next video will be fabrication of depletion NMOS, and once you get fabrication of enhancement depletion, the video will be fabrication of CMOS, which would be the combination of NMOS and PMOS. Please like and subscribe my channel. Thank you. Hope you like the channel. Thank you.